All right, as we finish out Chapter 3, we're going to look today at Lesson 3.8, which is on absolute value inequalities. And we've already looked at a couple of different things that we're going to kind of tie back together today. We've looked at absolute value equations and how we solve absolute value equations. And really, inequalities are solved the same way because it's absolute value. We're talking about distance from zero, and so because of that, we're going to end up splitting our inequality into two different ones, one with a positive solution and one with a negative solution. So we're going to do that just like we did with absolute value equations. And then also, because we have more than one inequality, we have a name for that. That's compound inequalities, and we've already looked at that as well, where we have and inequalities, where the solution to our inequality falls between two values. And the solution is the range that's in between those two. And then we have or inequalities, where we have the solution is outside of two values, one greater than the bigger solution, and one that is smaller than the lesser solution. And so we're going to kind of put those two things together as we solve absolute value inequalities here in Lesson 3.8. So first of all, on this slide, these are really just kind of the two different types of absolute value inequalities. In this first one, here we have a less than, right? Both of these are less than signs. When our absolute value is by itself, and it's less than whatever the solution is over here, or less than and equal to whatever the solution over here, then when we solve this, it's going to end up giving us an and compound inequality, which means that it's going to be between two variables. And so, for example, when we come up with our solution, we're going to have whatever A is, it's going to fall between these two values. And so it's going to be between the positive solution for B, so whatever the positive answer is for B, A is less than that, but A is going to be greater than whatever the negative solution is for B. So it creates this inequality, and whether that's just less than or if it's less than or equal to either one, it creates this and compound inequality. And on the number line, whenever we have the solution to this type of absolute value inequality, it's going to look like this, where we've got our number line, we've got like our solution that falls on the number line right here, and then our negative solution right here, and then our values that are going to be true for this type of inequality are always going to fall in the middle right here. Then whenever we have greater than, right, whenever our absolute value is greater than whatever the solution here is on this side, then what we know is going to be true is that we're going to shade to the outside. We're going to have this or compound inequality. So where A is going to be less than the negative B value, or A is going to be greater than the positive B value, or it could be equal to as well. So those are the two types of inequalities that we're going to end up with. We'll kind of walk through the steps for how we solve absolute value inequalities. The graph for these or absolute values looks like this, where we have our two values that are our solutions, and we're shading on the outside and shading on the outside. That's what our or graphs look like. But we're going to walk through how do we solve these absolute value inequalities, how do we end up with these graphs. It's really pretty simple. We're just going to break them apart into two, just like we did with equations. So here we go. The first example or first question that we have is what is the solutions, or what are the solutions to the absolute value of 8n is greater than or equal to 24. And so over here, we're just going to put our steps to solving. And we're going to just kind of walk through these. We can already see here at the beginning that because 8n is greater than 24, that it's going to be an or solution right here. Greater than is going to tell us it's going to be an or, so when we make our graph, we're going to be shading on the outside. But really, as we're solving this, we don't even have to worry about that too much. We can put that together at the end if we need to, if that doesn't make sense to you. So here's really our steps to solving. When we're doing absolute value inequalities, first, just like absolute value equations, our first step is to get the inequality, get the absolute value. By itself. So our first step is get the absolute value by itself. So before we can start solving this, before we can start getting the value of n, the absolute value, these two lines that are right here, the absolute value has to be by itself. In this case, it already is. Like there's nothing besides the absolute value on this side. There's nothing outside of it. If there was, we need to get rid of it first. But first step is get the absolute value by itself. In this case, it already is. Then step number 2, once the absolute value is by itself, then we're going to split it into two inequalities. All right, this is where we're creating our compound inequalities. In this case, it's going to be an or. We already said because it's less than. If it was, or because it's greater than. If it's less than, then it'll be an and we can put our answer in the middle of the two. But we're going to split it into two inequalities. And when we split it into two, one of them is going to have a positive solution. And so for us, that would be 8n is greater than or equal to positive 24. And then the other one is going to have a negative solution. And so, or we have 8n and negative 24. And when we do the negative solution one, this negative solution, we need to flip the inequality sign. Just like we do when we solve inequalities, when we multiply or divide by a negative number. Same thing here, when we change our solution to a negative solution, we need to flip the inequality sign. So instead of being 8n is greater than, like it was in the original problem, it's now 8n is less than or equal to negative 24. So there's our two inequalities. And then step number 3 is that we're going to solve for each variable. We know our steps to solving. Get the variable by itself is our ultimate goal. Do we need to distribute? Do we need to combine? All of those things that are kind of normal as we're solving equations. But ultimately, our goal is to get the variable by itself. And so in this first one, to get rid of our 8, we divide by 8. And what we do to one side, we do to the other. And so we're left with n is greater than or equal to 3. In our other one over here, we divide by 8. We divide by 8. And we get n is less than or equal to negative 3. So there's our two solutions. N is greater than or equal to 3. N is less than or equal to negative 3. When we're graphing it on our number line, we just need to make sure those two solutions are somewhere on here. So at least our graph needs to go from negative 3 to positive 3. If we have more than that, then that's fine. But we at least need to go from there. So I'm going to start at negative 4, negative 3, negative 2, so on. Okay, so there's my number line. I got a circle at 3. I have a circle at negative 3. Those are my two solutions. Because it's equal to, we can fill it in, right? It's equal to those numbers. Those values work. So we'll fill each of those in. And then for the solution at positive 3, it's greater than positive 3. So greater than, we shade to the right. And this is what our OR graphs always look like on the outside. And then for negative 3, n is less than negative 3. So less, we shade to the left, less to the left. And so there's our graph for this solution. So 3 steps. Get the absolute value by itself. Split it into two inequalities, one with a positive solution, one with a negative solution. And then we solve for each variable. All right, next example. In this case, right here at the start, our absolute value is less than, which tells us it's going to be and, right? We're going to have a solution that's in the middle. And so first step is get the absolute value by itself. In this case, it's already by itself, right? There's nothing on this side. except for the absolute value. And so already by itself. And so once it's by itself, we're going to split it into two. Again, you can split it into two separate ones if you want, but because it's an and, then what we know is our variable, or our absolute value here, is going to be in the middle, right, in this compound inequality. And so we know that it's going to be less than or equal to 5, like that's the positive solution for it. But we know it's also going to be greater than or equal to the negative solution, negative 5. So there's our compound inequality, because again, it was less than, it's and so we can write our variable and all that goes with it inside the absolute value in the middle here for our compound inequality, because we know it falls between negative 5 and positive 5. So then we're going to solve the equation. We need to get rid of two things, the 2 and the plus 4. To get rid of the 2, we're going to divide by 2. To get rid of the plus 4, we're going to subtract 4. We get rid of things in opposite order of operations, which means we're going to get rid of the plus 4 first. We do that by subtracting 4, and then what we do to the inside, we are going to do to the outside, or to all parts of our inequality here. So negative 5 and negative 4, same sign you add, keep the sign of the bigger number, gives us negative 9. On this one, different signs we subtract, keep the sign of the bigger number, gives us positive 1. Our plus 4 and negative 4 cancel, and so we're left with 2x is equal to negative 9, and 2x is greater than or equal to negative 9, and 2x is less than or equal to positive 1. And then we're going to divide by 2, and divide by 2, and divide by 2, and so we get x less than or equal to 1/2, and x is greater than or equal to negative 9/2, or negative 4.5, or negative 4.5, however we want to write that. So there is our compound inequality. There's our solution when we solve this by breaking it into two, one with a positive and one with a negative solution. And then for our graph, we just need to make sure that, again, both are included. So it needs to go at least from like negative 5 up through 1, so negative 4. And then our two solutions, negative 9/2 is about right here, right in between 4 and 5, halfway between negative 4 and negative 5. Then we're going to fill it in because it's equal to. 1/2 is between 0 and 1. Fill it in because it's equal to. And then x is in between those two, right? An and inequality falls in between those two, so we shade everything between the two values. And there's our graph for this inequality. All right, last example. A company makes a box of crackers that should weigh 213 grams. The inspector randomly selects a box to weigh. Any box that varies from that weight by more than 5 grams is sent back. What's the range? And so again, what we know about this when we're writing our inequality is whatever the weight of the box is minus 213, so like the difference between the weight and what the weight's supposed to be, has to be less than or equal to 5. Like that's the most that it could be. It can be 5 more or 5 less, and so because it can be on either side, then it's an absolute value. And then we start to solve. Because it is less than, then it's an and, right? It's a compound inequality. So we have w minus 213 is less than or equal to 5. But it also could be greater than or equal to negative 5, right? In either direction. And then we need to solve, so we're going to add 213 to both sides. And so when we find the solution, we get 208 is less than or equal to w, so the weight of the box has to be at least 208 or more, but the weight of the box has to be less than or equal to 218. So that gives us our range for our solution for what the box can be.